I am going to discuss this phase. Do you aware that you have already completed some of the phases in your life? Yes?
Yes, sir.
But this is the interesting phase that's going in your life. Am I right? Yes? You are going to attend your board examination by next year. Yes? You are in your important phase of your life. Are you all agreeing? Yes? Yes. But while at t is equal to 0, initial phase, am I right? Initial phase, how you people will be. How you people was there at that time?
Pre-KG.
Not. You are a small baby, am I right?
Yes.
In your mom's or father's hand, am I right? So that's one of the phase in your life. Like that, so many phases are there in your life. Are you all agreeing?
Yes.
Like that, I have shown the movement to and fro movement of this pendulum. Have you seen that there are so many phases in that movement of a pendulum while it is swinging to and fro? Yes, at one time it will be like this, at other time it will be like this, and at the other time it will be like this. These are some of the phases I am showing when the pendulum is in motion. Okay, so these are some of the phases. Okay, phase describe at which situation the particle is there now. Now, at which situation the particle is there. Okay, if I am saying this phase, if I am giving this answer for this phase, you can understand at which phase the metallic sphere is in now while it is oscillating. So it gives the situation that's happening now. But if I am saying initial phase or phase constant, it refers to the position when time is equal to 0. Okay, when time is equal to 0, at which position the pendulum may be? At t is equal to 0, that you are calling it as initial phase. This you note it down. When t is equal to 0, together I am teaching phase and phase constant. When t is equal to 0, that is known as initial phase. Initial phase refers to phase at time is equal to 0. Phase when time is equal to 0. Okay, so that one we are naming it as phase constant. How can you denote phase constant? With the help of symbol phi. With the help of the symbol phi. Can I please note down this? These phase and phase constant are very important for our next year. Initial phase when t is equal to 0, and it's also known as phase constant represented by phi. Yes, no? When t is equal to 0, what will be the value you are asking? It depends upon the situation, I think so. Okay? It depends upon the situation. When they are starting, when the movement has started. Okay? I will give you with a function, okay? The equation, that time you can understand. Okay? So phase refers to at which phase you are now. It describes, so many of the people are keeping status in our WhatsApp. Am I right? Like that, this phase refers to the status of the particle. It refers to the status of the particle. At which position the particle is. How the direction of the particle varies with time. Okay? Write down this equation. X of t is equal to a sin omega t plus phi. X of t is equal to a sin omega t plus phi. Here x of t refers to the displacement as a function of time. Am I right? X is your displacement and t is your time. The x of t is displacement as a function of time. At this particular time, where will be the particle? At this particular time, where will be the particle? Okay, that is your x of t. How can we say that? By knowing that A means A refers to your Joshita, A refers to your amplitude. Very good. A refers to amplitude. And sine is a function. Am I right? Sine, cos, everything is your function. Mainly, yes. Yeah. Mainly you will use this sine and cos function for your periodic motion. Okay, I will explain why we are using sine and cos alone in periodic motion in my next class. Okay, not now. Then omega is your. In our previous chapter, while we are discussing about system of particles, angular velocity, am I right? Omega means angular velocity. But here in oscillations chapter, we are saying omega as angular frequency. Omega means angular frequency. How we are denoting angular frequency? With the help of the symbol omega. So, how can you define angular frequency? I can define this quantity angular frequency, okay, by multiplying this frequency with 2 pi. By angular frequency can be defined by multiplying frequency with a factor of 2 pi. I will get my angular frequency. So, omega equal to 2 pi f. F already we know frequency is equal to 1 by time period. So I am re-altering this equation 1 as omega equal to 2 pi by t. Am I right? These two are important formulas for your next year also, upcoming year also. I can define angular frequency quantity as frequency multiplying by a factor of 2 pi. So that is your angular frequency. We can say instead of defining frequency as f, we can denote by with the help of a symbol nu also. Nu, nu, nu.